Okay. Right, as usual, we'll give it a minute for people to join. Right, we've got 29 now. Let's crack on. Hello, good afternoon, good evening, or good morning, depending on where you are tuning in from. So today is our 5th presentation for the webinar week with CSCP China. And we've got our panelist for today, Dr. Xinpeng Liu. He's our presenter for today, and Yunan Gao, he's the president of ICOR. Mr. Steve Tate, he's the past president supporting Yunan on his role with ICOR. And we've got Boei Zhang, he's the focal point from CSCP. And we'll start with Steve giving an introduction of ICOR.
Thank you. Hello, everyone. Thank you very much for joining this joint webinar with CSCP, the Chinese Society of Corrosion Protection. This is the 5th webinar of our series and the final one. So thank you very much for joining today. Our collaboration between ICOR and CSCP has extended over the past 12 months and has culminated recently in the signing of a new agreement at the International Corrosion Conference in October. And we shall continue to work together for joint technical events, awards programs, and future conferences. I've recently handed over myself to our new president, Dr. Yunan Gao. We've worked closely together for the last 10 years and we'll continue to work together for the next 2 years. We have a lot of combined experience, particularly in the oil and gas industry, and a lot of practical knowledge of that area. Supporting us, we have four trustees and 20 council members on the Institute. Thank you. Originally founded in 1959 as the British Association of Corrosion Engineers, we now are known as the Institute of Corrosion. Based in Northampton near London, which is about 100 miles from London, with 8 UK regional branches, and we're now expanding overseas to provide more of a service to our overseas members with branch possibilities presently in India and the Middle East, as well as our collaboration with CSCP. Our principal aim is to advance the understanding of science, technology and engineering related to corrosion control and to facilitate the exchange of information and ideas for public benefit. Thank you. This map just shows the distribution of our UK regional branches, so that they're fairly evenly spaced around the UK. UK has a population of about 70 million people, mostly in England, about 5 million in Scotland, and I think about 4 million in Wales. Thank you. Our current membership is around 1,500 members, of which about 400 are currently based overseas. So hence the reason for us to open local branches to help our overseas members. Thank you. Our technical journal is published 6 times a year, and we do invite anyone that's interested to submit technical articles for possible publication. Normally, these should be in the range of between 2,500 to 3,000 words with some high quality images. So if you just send those to our editor at icor.org, she will consider those for publication. Thank you. We are currently offer 3 grades of membership, the technician, member and fellow. And we also look into offer shortly direct chartered engineer status alongside our chartered scientist status for those that have been in the industry for longer periods. Thank you. We have 2 main divisions, our corrosion science division, which works closely with the universities and provides a number of awards. Our most recent conferences have been in Bristol University and Manchester University. Thank you. We also have a more industry-focused corrosion engineering division, which has an annual conference as well. The most recent one was held at the National Physical Laboratory, which is one of the government-supported institutes. Thank you. And finally, we have a young ICOR division, which recently completed its 2024 program with 24 graduates. The winners from that program are going to the AMPP conference in Nashville next year. They will also attend the AMPP leadership program as part of our MOU in place with AMPP. Thank you. And I think finally our sponsorships we've recently set up at University of Manchester for both undergraduate and postgraduate students to help them through the studies and to encourage them to get more closely involved with the corrosion industry and corrosion prevention. Thank you. And as I mentioned before, we have our 2 chartered grades of chartered engineer and chartered scientist for those that wished to progress to that level. Thank you. That's great. Thank you very much.
Right. Thank you, Steve. So up next is Bowie, and he'll be giving you an introduction to CSCP.
Hi, good evening and good afternoon, everyone. I'm Bo Zhang from Chinese Society for Corrosion Protection. And today is the 5th lecture given by during this webinar. And I will give a brief, quick introduction about CSCP and will give the stage to Dr. Lu to show what he has done in the generative AI in Cathodic protection. And CSCP is a member of China Association for Science and Technology, and it was founded in 1979. Now we have over 8,000 individual members and over 280 group members. And also we have 7 working committees and 25 specialized committees in different fields of corrosion protection. And also like ACRO, we also have different branches located in Beijing, Shanghai, and 15 other provinces and cities. And this is Professor Xiaogang Li, who is the president for CSCP. He is also a professor in University of Science and Technology, Beijing, also the director of National Materials Corrosion Protection Data Center in USDB. And also Professor Cheng Jueqin now is the Secretary General of CSCP. And we also have 10 vice presidents. They are from different fields of corrosion protection and institutes. And what we do mainly focus on the following 5 aspects. The first is for the academic communications. We organize the domestic corrosion and protection conferences. Every 2 years, we will hold a national materials corrosion and protection congress in China, and also we just had held a different kind of international corrosion protection conferences. And we also do some science and popularization, and we have our own journal and magazine about corrosion protection. And because there's a very huge market in China in the corrosion and protection, like the oil and gas and offshore engineering, we can provide the industry service and consulting to this industry. And we also can issue the standards and also can give the awards in this corrosion protection. And also we pay great attention on the international relations. For example, CSCP is a member of International Corrosion Council and the co-founder of World Corrosion Organization and Asian Pacific Materials Corrosion Association. And we have established a bilateral cooperation with the organizations from 18 countries around the world, like the US, the UK, Germany, France, Singapore, Thailand, and so on. And also we initiated different honors, like this corrosion awareness honor together with WCO and the EFC, and the Young Scientist Grant with WCO and also with AMPP. And like I mentioned, we can provide the training and the certification to the industries. And mainly we have 2 kind of trainings and certification. One is for AMPP, like the familiar CP courses, and also we have our own domestic trainings. And now we have trained for more than 60 courses and more than 1,020 trainees. Yeah, for the international collaborations, during the past 3 consecutive years, we held 3 big events in corrosion protection. In 2022, we held an International Congress on Materials Degradation and Protection, which is it's an online webinar. And last year, we held the 19th Asian Pacific Corrosion Control Conference in Guangzhou, China. And Professor Marcus, Herman Terry, Nick Bevelis, and also the people from UK, like the Anderberg, they all joined this event. And just last month, we held the 22nd International Corrosion Congress in Xi'an, China, and more international scientists and professors, they joined us, like Ian Moore and Raman Singh, Lee Graf, Emma, and Marcus. And also we have Stephen and Yunnan. And it was really a big success, I think. Okay, thanks for your attention. You can refer to the official website or this official WeChat group account for more information about CSCP. Thank you.
All right, thank you, Boe. So before we begin our presentation, just to let you know, for those of you who are in Aberdeen, we have our usual evening presentation at Palm Court Hotel tomorrow. So please drop by if you're there. And I'd also like to note that this session is being recorded, and if you have any question, please put them in the Q&A box, and they will be addressed at the end of the presentation. And for CPD requests, please allow us a week for a member of our committee to prepare and send them. And for our presenter for today, it's Dr. Xinpeng Lu. Dr. Xinpeng Lu is the CEO of Corrosion X Technology Co. Limited, based in Shenzhen, China. Dr. Lu has 18 years of experience in the field of corrosion and protection of oil and gas facilities, integrity management, and artificial intelligence. And he is also a standing director of the CSCP and specialized in the Specialized Society of Cathodic Protection Technology, member of Specialized Committee on Intelligent Diagnosis of Facility Health, and also a member of International Gas Union IGU Transmission and Distribution Committee. And Dr. Lu is also an EMPP member for the Cathodic Protection Specialist, CP4, Integrity Management Technologist, PCIM, and he is a manager level member of the British Gas Association, IGM, and a member of Standardization Committee of China City Gas Association. So Dr. Lu directed and implemented the Cathodic Protection Project as a gas and storage support manager, which won the highest award for civil engineering in China, the Tianyao, sorry, the Civil Engineering Prize twice in 2021 and 2022. Please join me to give Dr. Lu a warm welcome.
Thank you.
Thank you.
Hello everyone, welcome to today's online webinar. A big thank you to the Institute of Corrosion, ICOR, UK, and the Chinese Society for Corrosion and Protection, CSCP, China, for giving us this valuable opportunity to exchange ideas. This platform allows professionals and enthusiasts alike to exchange ideas, share experiences, and delve deeper into technological advancements in our field. First, let me introduce myself. My name is Xinpeng Lu, but you can also call me Rock. I'm currently the General Manager of Corrosion X Technology Limited, and I also serve as an executive member of the Chinese Society for Corrosion and Protection. I've been working in the fields of corrosion and protection, integrity management, and artificial intelligence for 18 years. Today, I'm very excited to share with you the advancements in the application of generative AI within the cathodic protection industry. The overarching objective of my presentation is to demystify artificial intelligence for the audience, especially focusing on large language models, LLMs, and AI agents that have seen revolutionary advancements over the past 2 years. These technologies are reshaping the way industries approach their challenges and workflows. This leads to a critical question. How can we use generative AI to transform our cathodic protection industry, or broadly, the corrosion protection sector? In this highly specialized field of cathodic protection, rapid technological advances mean that generative AI can offer us entirely new perspectives and methods. So, let us explore a pivotal question. How can generative AI serve as a catalyst for innovation within the cathodic protection industry and the larger corrosion protection sector? Let's start by looking at the market development of generative AI. I clearly remember the date, November 30th, 2022. I was working on a visual AI project for X-ray films when I stumbled upon some news, the release of ChatGPT 3.5. Naturally, I tried it out immediately, and it was truly mind-blowing. The outcome, as we all know now, was incredible. ChatGPT reached 1 million users in just 5 days and 100 million users within 2 months. Right now, the market for large language models is growing at an incredible pace worldwide. According to forecasts, the market is expected to grow at an annual rate of 79.8% from 2023 to 2030. Just imagine what this growth means. It signifies that generative AI is no longer just a lab concept. It's already in the market and impacting every aspect of our work. In the next few years, we'll see more innovative tools powered by generative AI entering all kinds of industries, including cathodic protection. The rapid growth of generative AI isn't just driven by technological advancements, it's also because of the enormous potential for practical applications. The latest OpenAI O1 preview model can already achieve an IQ equivalent to 120, essentially on par with a master's degree graduate. The mainstream large models have the analysis capabilities of a college graduate. These capabilities can help companies improve efficiency and reduce costs in their day-to-day operations. Especially in complex industrial scenarios, generative AI can automate a lot of data analysis and decision-making tasks, which is crucial for enhancing productivity and management levels. These capabilities enable businesses to tackle operational complexities, reduce costs, and increase productivity. In industries as specialized as cathodic protection, this could revolutionize data interpretation, predictive maintenance, and risk management processes. What's most exciting, generative AI can now handle technical decision-making tasks with precision. For example, it can analyze vast data sets of electrochemical readings to predict corrosion vulnerabilities. These predictions, which used to take weeks, can now be accomplished in mere hours, potentially saving millions in maintenance and repair costs. We all know some media promotion information. Since 2022, there are many general-purpose large language models available for us to choose from. The more famous ones are ChatGPT, Claude, Gemini, Grok, Llama, and other series. So the first idea that came into my mind was whether these general-purpose LLMs could be directly applied to the cathodic protection profession. After a series of experiments, we found that this idea is not feasible. The general large model lacks knowledge in specific fields, such as industry-related regulations, standards, and specifications. At the same time, there is a lack of understanding of the works, papers, materials, and data of specific industries. In this case, the general large language model can only answer general questions and cannot conduct in-depth and professional analysis and discussion in cathodic protection technical issues. Therefore, we hope to design and manufacture a large language model customized for the cathodic protection industry and expect it to perform relatively well in professional technology. Now, at the beginning, let's take a moment to think. What skills or qualities does an engineer need to be considered outstanding in the cathodic protection industry? I think we can roughly divide this into 3 aspects: the ability to understand and analyze information, a solid foundation of relevant knowledge and experience, and strong execution skills. Developing skilled professionals takes time and experience, but AI can provide a suitable solution in our current technological landscape. In other words, the technical architecture of the intelligent agent we designed needs to solve these 3 main problems: high intelligence, industry knowledge expertise, and professional scenario actions. When we talk about applying AI to a specialized field like cathodic protection, it's not as simple as just plugging in an existing AI tool. It requires customization to fit the unique needs of this niche industry. Specifically, this involves fine-tuning large language models using a technique called retrieval augmented generation, or RAG, and creating AI agents that are tailored to the field. Let me break this down for you. First, there's foundational intelligence. This comes from the AI's base model, which is improved through fine-tuning and pre-training. Think of it as giving the AI general problem-solving abilities. It's like teaching it the basics so it can handle a wide range of tasks. Next is domain expertise. This is where we incorporate specific knowledge about our industry. We use something called a vector database, also known as a RAG system, to integrate specialized information. You can think of it as adding an extra feature or add-on to the AI, kind of like a plugin for software. It gives the AI access to the most up-to-date technical references without changing the core model. Finally, there's execution capability. This is where AI agents come into play. These agents are designed to handle workflows, from analyzing data to generating detailed reports and providing actionable insights. When we bring these three components together, foundational intelligence, domain expertise, and execution capability, we create a powerful AI agent solution that can address the complex challenges in cathodic protection with remarkable precision. Pre-training a large language model from scratch requires a lot of costs. This cost may reach tens of millions of dollars or even hundreds of millions of dollars. Therefore, we are considering fine-tuning a specific general large language model to improve. When it came to fine-tuning the model, we didn't just use any data. We carefully selected influential works and materials provided by industry experts to build a specialized database. By conducting multiple rounds of fine-tuning and comparisons, we identified the most suitable version of the base model. The results were clear. This fine-tuned model demonstrated significantly better professional analysis and summarization abilities compared to a general open source model. In addition to fine-tuning the model itself, we also developed a set of structured industry-specific prompt phrases tailored for the cathodic protection field. These prompts help guide the model's behavior in a way that feels more professional. For example, we define an expert role for the model, set clear boundaries for its knowledge scope, establish interaction methods, and even dictate the format of its responses and the use of specialized terms. With these carefully designed prompts, the model's output not only becomes more accurate, but also appears far more polished and professional. Among these technologies, model fine-tuning and prompt engineering are relatively easy concepts to grasp. Fine-tuning means adjusting parts of the model to make it perform more to our expectations. In other words, seem smarter. Prompt engineering is all about optimizing the conversation process, content, and format with AI, which can make its responses look more specialized. However, the concept of an embedded vector database might be a bit challenging for those not in the AI field. So let me break it down into two parts. Think of the left side as an add-on. Yes, just like in video games. It acts as an extra knowledge source without modifying the model itself, just like using add-ons to gain extra functions in a game. When it comes to using RAG, we also store certain types of data in it. But you might be wondering, how is this data different from what we use for fine-tuning? Well, it comes down to how we classify the information. For general foundational knowledge that doesn't change often, like fundamental principles or theories, we include that in the fine-tuning process. This becomes the logical backbone of the model. On the other hand, information that updates more frequently, such as industry standards, new research papers, product specifications, or technical manuals, is stored in the RAG system. The advantage here is that we can quickly adapt to changes in industry knowledge. If there's a new standard or updated specification, we can add it to the RAG system without having to go through the time-consuming and expensive process of fine-tuning the model again. What's more, RAG doesn't just store this information, it allows for precise extraction and secondary processing, ensuring the content it provides is relevant and accurate. This combination greatly enhances the performance of the model while keeping it adaptable and cost-effective. The diagram here shows a rather complex RAG system. In this system, different types of knowledge are transformed into different vector databases, enabling us to select the appropriate content to match specific engineering questions. For example, in cathodic protection, if the AI agent needs to answer a very complex technical question, it can retrieve relevant content from the existing database or standard manuals through the RAG system and combine it with its generative capabilities to provide more accurate and detailed answers. A relatively new approach to RAG technology was introduced by Microsoft just 3 months ago, called GraphRag. This technology takes a significant step forward by incorporating graph structures into the organization and processing of data. It offers several advantages that make it particularly effective in complex and technical fields like cathodic protection. For instance, GraphRag organizes information using a knowledge graph. Instead of treating knowledge as isolated chunks of text or vector embeddings, it represents entities, like materials, equipment, or standards, as nodes, while relationships between them, such as relevance or dependency, are depicted as edges. This structure explicitly shows the connections between data points, which allows for a deeper and more meaningful understanding of the context. Another key strength of GraphRag lies in its enhanced semantic understanding. While traditional RAG heavily depends on vector similarity and can miss intricate relationships, GraphRag leverages the graph structure to analyze logical connections between entities. For example, it can determine whether a specific standard applies to a particular material under given environmental conditions, providing a more accurate and tailored response. What's also remarkable is GraphRag's ability to adapt dynamically. It enables updates to specific parts of the knowledge graph, such as adding a new node or modifying an existing relationship, without requiring a complete system overhaul. This feature is especially useful in industries like ours, where new standards, materials, or practices emerge frequently and need to be integrated quickly. One of the standout features of GraphRag is its capability for multi-hop reasoning. It can navigate through multiple nodes and relationships in the graph to answer complex questions. For example, it can analyze the properties of a material, assess environmental conditions, and check compliance with applicable standards, all within a single query. This ability makes it a powerful tool for tackling intricate problems. Moreover, GraphRag doesn't just retrieve information, it validates it through the knowledge graph ensuring that the outputs are not only accurate but also highly professional and aligned with the needs of specialized industries like cathodic protection. To better illustrate the value of GraphRag, let me share a practical example. Imagine an engineer asking, is a new coating material suitable for use in a high salinity marine environment, and is it compatible with sacrificial anodes? If we use traditional RAG for this, it would search documents or databases for mentions of the coating material and its compatibility with sacrificial anodes. While it might retrieve some relevant pieces of information, it could miss the broader context, such as the impact of environmental conditions or compliance with industry standards. This often results in incomplete or generalized answers, which are not ideal in a technical setting. GraphRag, on the other hand, approaches the problem differently. It first identifies the chemical stability of the coating material in high salinity environments, then evaluates its electrochemical compatibility with sacrificial anodes. Finally, it cross-checks all this against the latest industry standards to ensure compliance. The result is a comprehensive, accurate, and actionable response that the engineer can rely on with confidence. This combination of advanced data organization, semantic understanding, adaptability, and reasoning makes GraphRag a groundbreaking tool. It's not just an evolution of RAG, it's a transformation that's poised to redefine how we approach complex data-intensive challenges in our industry. This video will show us the construction process of RAG or GraphRag. For general RAG, the knowledge we output is scattered and random at the beginning. Through reasonable vectorization processing, the knowledge will be clustered according to the content in the library. We can determine which parts are related by calculating the spatial vector distance between different knowledge, and the knowledge with a longer distance will not be called. For advanced GraphRag, it is more complicated. These knowledge first have multidimensional vector distances in space to calculate the output probability, which is the process of general RAG. Secondly, the knowledge itself is also an entity, connected to other entities through internal logical relationships. In this way, when searching, other entities with internal logical relationships can continue to be retrieved. That is the line we see in the animation. In this way, we can not only retrieve the knowledge content that has been clustered, but also retrieve other related knowledge content with a longer vector distance along the logical line. Using these three techniques, model fine-tuning, prompt engineering, and RAG technology, we've built a demo AI agent specifically for cathodic protection. What you see in this screenshot is a very small part of this AI agent. You can see that it involves a relatively complex workflow, and the fundamental difference from traditional programs is that its main nodes are driven by large language models, which have the ability to analyze and solve complex natural language issues. In our testing, this AI agent also made mistakes, but overall, its level is not much different from that of an engineer with around 5 years of experience in cathodic protection. In cathodic protection inspection and maintenance, AI agents can help analyze data, generate predictive reports, and provide decision support for engineers. Cathodic protection involves a lot of electrochemical data, which can be quite complex and difficult to interpret directly. AI can analyze potential variations in pipelines to predict possible corrosion points. This is crucial for predictive maintenance, significantly reducing the risk of sudden failures caused by corrosion. Remember, it's only been 2 years since November 30th, 2022. This is an incredibly fast pace of development. I believe that every one of us in this industry should spend some of our spare time learning about AI. It will become an essential skill for engineers of the future, just like using telephones, computers, and the internet. At present, the AI agent for the Cathodic protection industry has obtained the intention and cooperation agreement of China National Petroleum Corporation and China National Pipeline Network Corporation. It will be launched in 2025 and will assist in the professional operation and maintenance decision support of cathodic protection in China's oil and gas long-distance pipeline network. In the latter half of this presentation, I want to show you some other applications of AI. When analyzing data, we often need to visualize it. Under complex conditions, we may also need to perform numerical simulations of cathodic protection potential distributions. Previously, not many engineers could do this independently. We often had to look for a collaborator who could write code. But now, with AI, things have gotten a little easier. The small program you see in the video is a demo I wrote to show the simulation of the potential distribution of a bracelet-type sacrificial anode along a pipeline. This program is about 700 lines long and, under traditional work conditions, would take a programmer around 20 days to write. With the help of AI, I completed the coding in 1 hour, fixed the bugs in 3 hours, and got it done in just 4 hours. This was unimaginable in the past because I did not have the ability to write large sections of code. My ability was limited to reading the code written by others with complete comments. With the assistance of AI, a product manager in an industry can independently create software for an industry under the condition of being sensitive to industry needs. Although it is just a small demonstration, it shows a broad future in the industry. In a professional field such as cathodic protection, there will inevitably be more and more work that can be done with programs, codes, and automation methods. I am more optimistic that in the next few years, there will be physical robots to assist us in some on-site work. Generative AI isn't limited to text. It can also generate images and videos. Strictly speaking, images and videos are even more effective for communication. They are more compelling and can help our industry have a more positive impact on society. Generative AI has significantly reduced the cost of creating these images and videos. As you can see, they are realistic and hard to distinguish from the real thing. We all know that the future of an industry depends on its current influence. Using traditional technical means, it is difficult for us to promote our industry in large quantities. We lack excellent directors, scripts, screenwriters, and actors. We also lack social capital investment. I remember that about 10 years ago, a movie called Deepwater Horizon was released, describing the explosion and oil spill of the Deepwater Horizon drilling platform in the Gulf of Mexico. This is already a rare publicity in the oil and gas industry. In today's diversified information, we need more publicity methods to pave the way for the future of the industry. AI image and video technology is the lowest cost and best method I can find at present. To wrap up this presentation, I want to share a short video with you. It's about a feature called Computer Use, launched by Anthropic in late October. You can look up the full version online if you like. In the video, the user wants to watch the sunrise, and AI autonomously searches for information, analyzes it, plans a route, and eventually creates a schedule reminder. the video showcases a very, very promising future. Not only can we use AI to create new functions, but we can also make use of the legacy achievements of past technologies, programs developed since the invention of computers and the internet, by driving them through AI. In this scenario, AI will serve as the brain that drives our work, taking on a large amount of technical tasks. All right, that's it for today's sharing. I'd like to conclude by saying that generative AI has vast potential for applications in cathodic protection, greatly enhancing our efficiency and decision-making capabilities. Thank you all for joining.
Right. Thank you, Dr. Lu. That's a good video presentation. So we're going to our Q&A session. So we've got our first question from Sunday Sampson. So how does the AI determine if a standard is applicable to a particular material?
I see the question says, okay, so how do the AI determine if standards are applicable to a particular material? Also, I think it depends on the how we build the right system. So we choose a foundational LLM. So when the LLM is be chosen as a local IQ, or we said how it can do the things, the ability is determined. So when we do the right system, AI can we can write the right system by some sentence or some materials to write standards or papers suitable some certain materials. So it depends on how the right system, but also it is the most complicated in the total system. It's difficult to build this. Okay.
And also, second question from Sunday Sampson. What is the percentage of error in data analysis versus if it is done by an engineer?
Oh yeah. I think in the presentations I said uh, uh, don't don't say AI is a specialist or experts in the industry. No, it's only assistant for you. So I think through our research, it's mostly equal to 5 or 10 years has master degree engineer. It means equal to humans. I think more or less 30 age. The humans engineer age like 30. So if you make the percents, that means if you compare to the young graduate students, it has better answers. If you compare to the experts, I think only 70 or 80% of the experts. But another in other side, the AI is only developed for 2 years. So I think the next year, 2025, we have better AI. So the percent is increase a little. 2026, we increase another little. So AI can improve itself, but for 1 year, another year. But I think the engineers cannot do this so easily, especially in an area we have hundreds of engineers, thousands of engineers. So how we can improve all these engineers levels? It's difficult. So even we only have 70 or 80% of the ability of the specialist, but it has a great potential in the future. Okay.
All right, thank you. And another question from an anonymous attendee. How do you think we can use AI while ensuring new generations of engineers still gain the knowledge and experience they need to eventually have technical oversight over AI designs and decisions?
Great. That's a great questions, but not only in I think not only in the CP area or Corrosion area, but also in all of the AI use area. You know, in the past, the knowledge is very expensive because when we want to translate the knowledge, we need people. We need special people to special people. We have few teachers and more students to translate to transfer the informations. But when we use AI, it's easy to transfer the informations. So in the future, it must be AI assistant you to get the informations. We need to know this. AI can make mistake even in simple questions like 1 plus 1 or 2 plus 2. Maybe it has the mistake. So we need when we use these AI functions, we need to take care. In our work, we have a certain specialist to see. Today we have for example, one day we have 500 questions for one day. We have a specialist to reading all these 500 questions, and if there are something wrong, we will connect to the users and say to the users some sentence the AI make mistakes. That's our ways, but I think in the future we have better AI can make less mistakes. So
Right, thank you. And another question from an anonymous attendee. Given the fast changes in AI, can the system be future-proof from breaking with updates?
I think depends on the technical technologies right now. It's difficult to. I think it's difficult to. mm it's difficult. I think as right now it's difficult. But I have a I have a I think in the future maybe we will have a new technology. Not depends on today we use the transformers models because transformers models is developed. I think it, normally 8 or 9 years ago. Now we have a more and more high technical LLM uh, models, not only the transformer models. So I think in the future, a new systems depends on the new LLM models can do this. Not right now. Not right now. Okay.
Right, thank you for that. So I think that's all our questions for today. With that, if there's any more questions, please put them in the chat box or the Q&A box. Otherwise, I'll close this session. Right, okay. There's another one from Maizura Muhammad Sani. How many data should be used to train the AI to ensure its high capability and accuracy? Can it detect type of anomaly in the voltage?
Oh yeah.
If yes, yeah. Can we suggest the next action to take?
Yeah. So for the dates, for the how many dates, or for the large, I think I use more or less 400 standards and nearly 100 books to train the AI. Or when we say words or promotes tokens. I think nearly thousand. No. 1,000,000,000. Yeah, 1,000,000,000 words. Nearly this. So we found the situations. If we use more words, the mode is better. But we have another side. Use less words, exactly words. If you have better dates, the few dates can make the most better. So how many dates? It depends on the quality of the dates. If you have high quality dates, you can use less dates. But if you have normal dates like specifications, standards, or books, I think maybe you need to use hundreds books. Okay. So another question is test the normal of the voltage. Oh, that's the easy questions. I think the normal in the voltage is easy questions. Now, right now we can answer the questions like these levels. I send the AI reports like maybe 300 page of the papers, or 300 or 500 page to the AIs, and AI reading the reports. It can give me the all anomals in the reports, and it can give me the instructions how to do the actions to repair the pipelines, or to repair the CP systems. I think it's more complicated. Okay, so there's different levels. We already passed the questions levels like voltage anomaly. We already passed this. Okay. Thank you. We lost your voice.
Oh, sorry. So, an anonymous attendee, for someone new to AI, where does a corrosion engineer start from?
Yeah, good questions. I think for nearly almost us, we are new beginner. For me, I'm not graduate for AI in the university. I'm graduating electrochemistry. So how do I start? I think mostly is interesting. Everyone has his own time. If you're interested in some area, you can spend this time to the area. You can spend some to some I think presentations, technical papers, or try. That's very important. Mostly important. Try to use a real AI model. Try to use. When you use the real AI model, you will find, oh, it's really good functions, but it has some mistake. So maybe you go to another AI mode. When you use the second AI mode, you will see, it's better or it's worse. It's like if you watch the TV, you put in the first tunnel, or watch the movie. You watch one movie, another movie, 3 movies, 5 movies. You are better. You focus on the movies watching. So you have experiments to see the movies. If you use AI, let you use AI, focus on the AI. More time, you have experiments to chat to AI. So I think the how to start to use the real AI mode in your work. Okay.
Right, thank you. So that's all the questions for today. And yeah, in case most of you did not notice, the presentation was given by AI. And thank you, Dr. Liu. And with that, I'm going to end this session. Thank you all for attending. We'll see you next year, probably.
Yeah.
For the next.
At last, we need another notice. The video today I show you. It's not the recording for me, but the AI makes the video, makes the digital humans, digital sounds.
Right. Okay. Yeah. Was it presented live and converted live as well?
Yes.
All right. Okay. That's good to know. Right. Thank you. Thank you, Dr. Liu. That's new to us.
Thank you. Thank you.
Right.
Yeah. You. Hi, Stephen. You want to give a summarization about the webinar, or Yunnan?
Yunnan, do you want to go?
Yeah, I think on behalf of the ICO, we would like to thank the collaboration from CSCP and all the very enthusiastic for attending this webinar for the past 5 days, nights, and I think there's a lot of, it's a great success. I think everybody will join me and believe. As Bowie said, so for next year, we'll do something even more exciting and helpful to benefit not only ICO, but also CSCP. And appreciate so everybody can follow us in social media, in news. We would like to know, and with this like a strong hand-in-hand collaboration, we will have do something more to the global corrosion community for sure. Yeah.
Thank you. Yes, we'll certainly work together to continue our collaboration with CSCP during 2025. So we very much look forward to that continued involvement with the CSCP team. Thank you.
Yeah, thank you. I just yeah, on behalf of Professor Lee, I think he look forward to meet you again in UK next year, and hopefully we can maybe can have a now webinar but seminar in somewhere in UK. Yeah, we can discuss later.
Yeah, sure, for sure. Yeah.
Yeah.
So until next time, everybody, bye.
Thank you very much. Thank you very much.
Thank you, Dr. Liu. Yeah, thank you.
Right. Thank
Cheers,
you.
Mary.
Bye.
Thank you.
Bye.
Bye-bye.
Bye.
Cheers, mate.